This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 30 and the last session of 2020. Hope everybody's staying well. Before we get started, happy holidays and happy new year to you. Hope you're staying well as your family. We've got a great presentation today on Midwest Winter Satellite Challenges and Opportunities from Patrick Ide, the Science Operations Officer, the Weather Forecast Office in Duluth, Minnesota. Our facilitator for today is Dan Lindsay, who is the GOES-R Program Scientist. Just a few reminders before I turn it over to Patrick. This session is being recorded, so if you have any colleagues that are unable to join us today, they can go on the VLab and watch this presentation later. We will have opportunity for Q&A after the presentation. Please feel free to put your question in the chat and we will use that to field the questions that we receive. We're always looking for future presenters, so if you are at a field office and have an application to share with your colleagues, please get in touch with us. I'd also like to point you to Brian Mata if you're looking for training materials specifically related to satellite or otherwise. He can help you develop those materials or point you to where they are. I'd just like to thank the Tower S team, specifically Kashad Bowman, who is helping organize these webinars, as well as the OCLO, GOES-R, and JPSS teams. Without further delay, I'd like to introduce Patrick, who's been the Science and Operations Officer at the Weather Service in Duluth since January. Previously, he worked for 12 years at the Weather Service office in Bismarck, North Dakota, and was a SCEP at the NWS in Grand Forks, so staying in offices that border Canada. Patrick has developed multiple reference guides and has given several presentations at workshops, conferences, and training webinars on GOES 16 and 17 topics. Patrick, looking forward to your presentation today. Hope you're staying well.
All righty, thank you very much, Jordan. Appreciate the opportunity to be here. And if there's any audio or video issues, just let me know. It's always interesting, even after all these opportunities here. Always run into a snag, I'm sure. But appreciate it. So I was asked to kind of give a take on strategies or challenges and opportunities. So this is really going to be a presentation that's really heavy on any case studies, more philosophical. So I think it's important right off the bat to just look at what do we got, which is pretty amazing. And this is one of my favorite screen captures that and I have a ton of them saved on AWIP, strewn about Bismarck and Duluth's offices. This is one of my favorites. I think this is from like March of 2017. This is obviously the day cloud phase RGB, and just amazing, really, what we can see. How many different processes stand out, the different thermal regimes, even in the snowpack. We can see where the Arctic air is blasting into the north, where the red is bleeding in more into the RGBs, and compared to the green snowfall across the Minneapolis area. But there's so much going on here, including the convection across South Dakota. So, before we dive into, boy, gee whiz, I'd like this in the future. Wow, just one really simple RGB, and look how much power it has. Look at all the different processes, the different things that stand out. So a huge benefit before we go too far into looking towards the future. So I just wanted to share that off the bat. So what is this presentation? Well, it's really just kind of questions and musings, ideas from a field perspective on winter satellite strategies. And opportunities for the future. Where are the challenges, and what could the field really use? I don't know how much all is possible or not, but we'll throw the ideas out there for sure. So, obligatory convective loops, even in a winter presentation. So, obviously, winter is a different set of challenges. The simple one is just less light, right? So. A lot of our RGBs that have a lot of visible dependencies, they're just you just don't have a lot of daylight to be working with to be utilizing them. Also, if you just think about how much application there is in summer convection, where there's a ton you can see in the cloud top trends, and it's just not necessarily as much per se in the winter because we have a lot higher dependencies on those in-cloud processes. And then just the larger synoptic scale systems, you get the cloud shielding that's covering a lot of that anyways. So that the long visible loops that show us so much from initiation right on to decay, just don't have that, one-to-one crossover into the winter as easily. And there's just, not as much, at least initially, on the cold season training, the applications, the meso-analysis, as there has been for summer. And I think Randy Bowers is from Norman's going to follow up for the next presentation in the book club, talking about that winter meso-analysis. So the conversation started, but it's definitely a little more in its infancy compared to the warm season meso-analysis. So different set of challenges. So what are the opportunities? So I was thinking about this for the past month since I've been asked to do this, and also put a bug into the ear of our forecasters. And so what do we want to see? What could really help us out? So really three things came to mind, and kind of very similar to what our forecasters also came up with. I think there's opportunities for multi-sourced, winter-centric fused products. So kind of a mouthful there. But some of the things that we've seen, like with more of the prob severe, we'll get into that, and kind of the flight category probabilities. Can we get something out for some of the winter things? Snowpack and lake ice condition, whether that's the snowpack condition for the Northern Plains or what's going on in Lake Superior for lake ice. And then probably just as relevant for the summertime as well is that low-level thermodynamic and moisture retrieval. So I think a top priority for us is filling in the gaps with satellite snowfall rates. And so, this is the merged satellite snowfall product, MSSFR. And I think what we really are interested in is filling in the gaps that even this merged product, as it transitions in, it's still tied to that radar quality score. So we need a little bit better retrieval for all the gaps. And so just look at my CWA, there's a lot of gaps. And a lot of gaps where there's high recreation within the winter. And so that's one thing that not only myself, but another forecast really agreed with. That was one of the first things that came to mind is gap filling satellite snowfall rate products to help fill in the radar gaps. But can we break away from being tied to some of the radar quality scores, which kind of preclude us from filling in those gaps between all the radar umbrellas? And even my old office back in Bismarck, basically the western third of the CWA is kind of void of a lot of at least AD/AD covers. There are some state radars out there, but not so much luxury for us. So really a top priority is how do we fill in those gaps with some type of fused satellite snowfall rate product to help us out. And again, is there a way to get away from being tied to the radar quality score? And that's beyond me. It's an idea I'll throw out there. And I know there's satellite and radar scientists far better at answering that question than me, but really a top priority, I think, for a lot of us across the Midwest. So another thing that came to mind is we have prob severe, right? What about like prob snow squall or prob freezing drizzle, something like that? So this is a day cloud phase image from, it's on there, November 25th. All right, so a massive expansive stratus deck across the region. Well, for that whole stratus layer, well, where's the freezing drizzle threat or not, kind of? So can we mix the satellite NWP, maybe even road temperatures, with some of the things that like Heather Reeves has been working on with the NSSL 1 hour look ahead for the sub-freezing road temperatures. Can we fuse all that data together to get us maybe some type of prob freezing drizzle polygons or something? Where in this stratus layer is the freezing drizzle? Can we apply that to like a prob snow squall? So taking like the prob severe approach and applying it to winter hazards, and whether that's a polygon like prob severe, kind of like we predominantly display it in our AWIPs, or something akin to the fused flight category probabilities, the probability of IFR and MVFR. So really, another kind of secondary thing that really jumped out to me is these fused winter-centric products. Taking the kind of the model of how we do that for like Prop Severe, can we apply that to some type of a winter hazard, whether that's freezing drizzle, whether that's a snow squall, something like that. Winter mesoanalysis. And again, Randy Bowers is going to follow up on this, and this is something that has been tossed around by a lot of the students up in the Midwest. Is, well, we have a big push on summer mesoanalysis. What does winter mesoanalysis look like? It's definitely different scales, temporally and spatially, that we're looking at. So a few things that come to mind is from this, what can we, is there any way to bring out vertical motion or divergence or frontogenesis or deformation fields? Can they somehow be derived somehow based on anything in the satellite? I'm not sure the feasibility of that or not. How much, a lot of it probably has to do with, especially from a geostationary standpoint, the derived motion winds that are just not at every level based on where the clouds are. But is there anything that we can bring out, whether it's through fusion, whether it's through polar and geostationary, to bring out, satellite-derived vertical motion, divergence, frontogenesis, deformation, to be applied to winter mesoanalysis? And then a big question that I think we're really, just starting to even really think about, and really are thinking about this is largely due to the arrival of GOES 1617, is, how can we modify our summer mesoanalysis practices to the cold season, and what does that look like? And that's something that, again, we're really just starting to think about. And it's our challenge, right? It's really things happen much slower. So what does that look like? But then there's times where things can quickly ramp up in the data as well in winter. And with winter, there's a lot of DSS that needs to follow up. There's a lot potentially more intensive grid edits that need to follow up as you're trying to parse out snow and precipitation types and things like that. But especially what is cold season mesoanalysis? What does that necessarily look like? Because it's not necessarily going to be one-to-one to summer. So it's something that we're just really trying to think about. Don't really have an answer to yet. And a lot of this also gets back to training as well. That I think I know myself, probably place a large, easy emphasis on the summertime training for summer convection. And I think, I know myself need to circle back and what can we really do to kind of bolster our satellite interpretation for the winter. All righty, loosely related, we'll just kind of roll through all these topics. Low-level thermodynamic and moisture retrieval. Obviously, something that's talked about in the summer as well. Is, can we really improve our data reliability and availability, especially when the first 5,000 feet AGL, big impacts to precipitation typing, right? So, and that's either from just simply pulling up that sounding, if it's from new caps down the road with that improved capability, to fine tuning of NWP. To then even just influencing the research and tuning some of our methods from a forecast methodology standpoint. But low-level thermodynamic moisture retrieval, obviously big for the summer, big for the winter too. It's really there's so much happening in that first 5,000 feet that has such big impacts on are we getting a sleet? Are we getting freezing rain? Or are we getting a mixed mess? And obviously P-typing is messy. So anything that we can do to help that out, being up here in Duluth, we're, as a lot of our offices are, we have soundings around us, but there's a lot that happens in between them. So the new caps is a huge plus, but if we can really bolster the availability and reliability of that first 5,000 feet of thermodynamic moisture, boy, that would really help us out. Another thing that comes to mind is in-cloud phase. And so what you're looking at is the snow ice band 1.61. And so this is from December of 28th of 2017, Chanhassen into the La Crosse area. It's cold, single digits, and it's snowing, which makes sense. But what caught our eyes, and we've done a couple presentations on this, is why the cloud tops are super cooled water. It's the really light coloring to the clouds. Shouldn't that be all ice? It's snowing, it's very cold Arctic air. And so we looked at the research, and Sims pointed us to the this Arctic air mass cloud stratification. So the cloud top phase is great, but in this case, it's kind of counterintuitive to what you would think, that it's Arctic, it's snowing. Shouldn't the color just be dark gray? Shouldn't we just have ice crystals there? But there's this stratification of phase within the cloud. So, which gets to the cloud top phase is great, but what really is important is, well, what's that phase look like within the cloud, within the depth of the cloud? And that gets right to the heart of a forecast problem with a lot of WFOs is our precipitation type methods are very heavily dependent on cloud ice presence. And that is the trickiest grid that we have that has big impacts. So whatever we can do to help us out, a lot of our methods are based on aircraft observations for ice presence. Well, operationally, there's pre-existing ice crystals maybe in the column from some source region coming from Canada, or vertical motion is promoting an ice crystal growth at warmer temperatures than what our curve within our methodology would necessarily suggest. So being able to get at the in-cloud phase is something that is, again, big for precipitation typing. And also lending itself to applications of just not operationally just looking at the data, but then using that to fine tune our methods downstream of that as well. Snowpack condition, that's a picture of my former backyard looking across into the valley. It looks like Antarctica. So snowpack condition. So this harkens largely back to the northern plains. And snowpack conditioning, characterization, and temperature. So one of the biggest challenges we have with blowing snow, it's not that is it going to be windy. We know it's going to be windy, but is what's the snowpack condition? So is it a glacier or is it a bunch of fluff? And to be honest with you, what we would kind of do, I go walk around the back of NWS Bismarck, kick the snow around in the field a little bit and say, it seems kind of loose. Maybe it'll blow it, or we get these clippers that come across and they build a little bit of crust, but then we know we're going to get this big push of wind. So what's the snowpack condition? And then for hydro, is the snowpack about to unleash its water or not? So here's a MODIS image, I think from last year or something like that, just a massive snowpack, all right? So snowpack characterization and temperature, it's not overly time sensitive, so we can really take advantage of polar. And what can we steal from our sea ice products? There's age, there's thickness, there's coverage, there's temperature products for sea ice. What can we transfer potentially over to snowpack to give us snowpack characterization and temperature? So for this massive snowpack across the region, where is it crusted and really unlikely to become lofted by strong winds? Where is it not really crusted, a little bit more fresh, and it's able to become lofted? So it's either 50 miles an hour and 10-mile visibility, or it's 50 miles an hour and you can't see your hand in front of your face because of a ground blizzard. Well, a lot of that is so much tied to the snowpack condition, not necessarily the winds. And then, from a hydro standpoint, where's the snowpack ripe for melt? So I'm going to play this loop. It might be kind of hard to see, but this, which also gets to a point of something that I'll mark on. So credit to Carl Jones, NWS Grand Forks. You see kind of these horizontal convective roll cloud looking things across the Red River Valley and into South Dakota as well. So they saw this feature like, oh, what is that? Oh, it's blowing snow. So you can see the blowing snow on the satellite ripping down the Red River Valley. And here's another example from last year. You can see, how the blown snow stands out within the day cloud phase RGB, likely due to the fracturing of the ice crystals. And you can see the extent of the blizzard conditions right here with kind of the horizontal roll-looking clouds, half-mile, quarter-mile visibility down the Red River Valley, gusting 45 knots. So there's big impacts here, right? That's probably closing down a major interstate. And the predictability of this has to do with largely on the snowpack. And what we have for our current tools using the Bagley blowing snow model, it's largely tied to snow age. It's very simplistic. So is there a way that we can get at snowpack condition to know, are we going to be ripping at a half-mile visibility, or we're going to be over here in Jamestown with 10 miles? Big impacts. So thank you, Carl Jones. So that that gets to the heart of why the snowpack condition matters. Over the domain, where can it be lofted? Where can't it be? And maybe we're bringing in snow from southern Canada and blowing it down into the States. So obligatory Great Lakes ice picture. I think this is from 2 years ago. This certainly was not what last year looks like, certainly not what we look like now. But this gets into something that a subset of our offices are going to be looking at. I include the Duluth office and Marquette office, is these GOES cryosphere products. So ice concentration, ice age and thickness, and even ice motion. So again, why does this matter? Well, there's the Herbert, I believe that's the, might be the Oberstar. One of our Great Lakes freighters of the classic style, which I really like. So the Great Lakes shipping IDSS, huge as we get into, we got about 4 weeks left of the shipping season until the Sioux locks close, and then they'll open again in March, mid-March. So Great Lakes ice IDSS is huge. We have our port meteorological officer here in Duluth who provides outstanding IDSS to the Great Lakes shipping fleets. We have our Cleveland office with their ice desk. So Great Lakes ice shipping IDSS is huge. And we want to be able to, what can we gain from potentially some of the geostationary products? Can we do difference fields of how much the ice pack is growing or not? Where's it thickest or not? Is there some characterization to it? There's lake effect snow impacts, which we'll get to. And then there's even ice to land blowing snow. So even though we're, massive amounts of trees up here, build up that ice sheet, we can get, potentially some pretty bad visibilities coming off the lake from blowing snow. So it's not just about ice presence, but about ice characteristics. So this is from the National Water Center, which they sent out to Sean Carter. And so this is sentinel imagery of Red Lake, Minnesota, which is just outside of our CWA in Duluth, in the Grand Forks CWA. So we can see all the cracks in it. So it's not just about, is ice present or not? It's about, is it a solid sheet or is there cracks? Because if there's cracks or if it's slushy, there's still some heat transfer there. And so you're still going to be able to generate some lake effect, even though there's ice on it. So until we completely seal it off, you still have heat transfer and are still able to generate lake effect snow. So it's not just simply about a yes, no, ice is present, but characteristics of that ice, of what does its heat transfer look like or not. And then finally, a remote sense water column temperature. These are large observations of water column temperature within the Great Lakes, are very few and far between, and they are heavily tied to buoy deployments. Most of those buoys get yanked out, are already yanked out. So is there any way we can kind of get this sensed water column temperature? So wrapping it up, and we'll open up to questions. So where are the opportunities? Well, again, multi-sourced fused products, I think. Snowpack and lake ice condition, and then the low-level thermodynamic and moisture retrieval. So that is all I have, and so I will open it up to questions. Let me turn that back up my volume. and I appreciate it.
Thank you so much, Patrick. That was a great presentation, and we do have some questions coming in, but since we're getting close to the bottom of the hour, I'm going to go ahead and wrap it up here, and then if you can stay on and people that are interested can stay on, we'll have a little bit longer time for some dialogue here. But very good presentation. So just like to ask for your feedback. For those of you that do have to head out now, we have a link in the chat there. Just like everybody else these days, we want to know how to make this the most effective use of your time. So please let us know what you'd like to see in the Satellite Book Club. Our next Satellite Book Club seminar will be on Thursday, January 7th at 12 noon Eastern Time. Randy Bowers, a meteorologist from the Oklahoma City Norman Forecast Office, is going to discuss the mesoanalysis of winter storms. And look for an email from the Tower S team after the holidays. We really appreciate you joining us. For those of you that attended multiple Satellite Book Club seminars over the course of the year, we hope to continue this in 2021. And stay well. Have a good holiday, everybody. And I'll turn it back over to Dan Lindsay to lead the Q&A. Thank you.
All right, thanks, Jordan. And yeah, I echo Jordan's comments. That was a really tremendous presentation, Patrick. It combined two of my very favorite things in the world. Number one, winter weather and snow, and number two, satellite imagery. So I couldn't ask for more from my perspective. I'm sitting here extraordinarily jealous of everybody in the Binghamton area after the snow race that they had last night. So yeah, I have one question and then we'll get to some in the chat. The question is, what has been the single biggest contribution to winter operations from GOES 16 and 17?
Sure, thank you, Dan. So I think it gets back to really that first slide there of, if I can get back to it myself. And I think that tells the story there of how many processes stand out and jump out that really never did before, whether it was from latency, whether it's from resolution issue. But I think largely these are the RGB, this day cloud phase RGB has been absolutely tremendous in just opening our eyes to all the different processes and making it so easy to pick those out of the satellite imagery. So cloud top phase has been a big one that we can get to. And then from that, all the kind of the secondary processes that are able to jump out. So you can see, Arctic air intruding into northern Minnesota. We can see, boy, it looks a little more red and yellow up there. So that's Arctic air compared to the green snow of Minneapolis, the convection across South Dakota, and all the other different cloud top phase typing that we have. So that's really been a massive help to us. So it's hard to really state correctly how big GOES 16 and 17 has been, which has been stated well long before. But just look at this one single image on a day in March, and just look at how much power is in this one image.
Yeah, I couldn't agree more. Before continuing the questions, I meant to tell everybody, if you do have a question, please either type it into the chat box, or if you want to ask it verbally, just make a note that you want to ask it verbally, and I think Lee or someone can unmute you at that point. Just one quick follow-up question about the RGB stuff. You showed the example from Carl of the blowing snow, and I remember him talking about modifying some of the RGBs on the fly in terms of ranges and things like that. How often do you or your forecasters actually do that, of get in and start modifying some of the RGBs?
Sure, so that's a really big, that was one of the other topics that really came up as well, which I meant to touch on, but I'm glad you asked the question, is for us being so north, it's dealing with the seasonality of the color curves is huge. And whether it's the color curves just from visible, like I got to crank visible way down, otherwise it's just super dark, so I got to change the color, just the range on the visible. And then, having to adjust like the day cloud phase, the composite options, which we have in AWIPS, it's a big deal of being able to have to tune these to the seasonality. And so that's something that our forecasters often have to do, especially, you get used to what that looks like in that day cloud phase looks like in the summer. And now in December, it's just dark. It's really red. It's just not as usable. And so we're having to go in there and play around with everything, whether it's even water vapor, all the bands. You got to have your winter and your summer ranges to be able to make them usable. So, boy, if there was a way to dynamically do that and I know it's hard because we go from the poles to the tropics, and so, but if there's some way to almost have setups that are pre-made or tuned to the seasons based on latitude, that would be big for us.
Yeah, I know exactly what you're talking about, and it's impossible really to pick a color curve or a set RGB recipe that works perfectly everywhere. So I strongly encourage people to mess with your visible ranges or whatever you need to do in order to bring out the feature that you're looking at. I have one more quick question, and then I'll go to the audience questions. The next one is, what's been the most significant challenge for training forecasters on winter satellite challenge or strategies rather?
Sure, that's a good question, in that well, I just think about when it got deployed, right? When it got deployed was Go16 came out in like the spring, right? So it was the new fancy toy for the summer. And so immediately there's just this wealth of cases and looking at, wow, look at what we can see in the summer, and it just kind of propagating and carrying that off to our conferences that fall and winter. And I think it gets back to as well that there's so many really quick wins with convection in summertime, and that going to the winter, it's not so much just about watching the thunderstorm grow, but it's also gets back to, well, if I want to teach what you're looking at on the satellite there in the winter, well, I really got to make sure I'm refreshing you on some of these synoptic conceptual models that maybe you haven't really visited too much since your winter walk course, or maybe your synoptic courses in college. So I think that's part of the challenge is that's not just on the satellite, but it also gets back to, as it does in the summer, just as much of an emphasis on getting back to the basic conceptual models synoptically as well. And so it's a broad refresh, I think, that's required. There's quicker wins. There's just more of a wow factor of looking at some of the satellite products, especially for the summer. And so now I think like what we're seeing now with Randy's follow-up presentation of, okay, how do I apply that to winter? There's having to tease out different things, and boy, I really probably have to really freshen up on some of my basic heavy banded snow ingredient conceptual models. Okay, now what does that look like in the satellite compared to looking at NWP? So.
All right, thanks, Patrick. All right, let's get to the some of the audience questions that are in the chat. The first is a comment from Bill Schoberg commenting about the snowfall rate product from One Ming. One gave the seminar just a few weeks ago. Seminar from December 14th, and there's a link there in the chat. So maybe check that out. It's a microwave-based product from Polar Data to give some good estimates of snowfall rate. The next is a sort of a question comment from Scott Lindstrom speculating whether the Mears rain rate product can help with a freezing drizzle problem. Yeah, I don't know the answer to that, Scott. Like you say, that it seems like there may be a lower bound of rain rate, and of course drizzle is extremely low rate, so I'm not sure about that, but it's something that we could probably follow up on. And then here's another comment from Scott Lindstrom talking, apparently Dan Baumgart, who I think is the Sioux at La Crosse, or was, is talking about that 2017 event that you showed at an FDTD webinar on Wednesday, 6 January. So, oh, sorry, that's coming up. I misread the comment. So there's a link there. If you're interested in that event, join the link that Scott sent there in the chat on to hear Dan talk about that event on 6 January. Here's another comment from Bill Schoberg. Consider bringing in the higher resolution of the JPSS satellites for snow products. That is, of course, the big advantage of the JPSS VIIRS imagery is the super high resolution. Lee, okay, so let me just keep going here. Another comment from Bill, Comet is working on an RGB training module. Thanks for reminding me of that. And so look for that. I don't know the exact TBD on when that'll be done. Sometime in 2021 calendar year, probably in the first half. So look for that to learn a little bit more about some of the RGBs. All right, here's a question from Bill Line. Have you investigated satellite signatures of localized snowfall from anthropogenic sources? And has this influenced forecasts and nowcasts?
Yeah, so we have, that's something that we actually deal with quite often up here is anthropogenic snow, whether it's from various sources across the region. So one of our forecasters actually just finished writing a paper, I should say, yesterday on that to distribute it to our staff. And so that's something that we actually do deal with, and it impacts one of our TAF sites, if not two at times. So he was looking at some of these satellite characteristics of that, and I think there's opportunities to carry some of that forward. It's definitely something that we are really battling quite often, actually, just based on where we are. So definitely, that's something that Kevin from our office has been working on. And so I would, you might already be in contact with him, Bill, but if not, we'll get you in contact with Kevin from our office, and that's definitely something that we've looked at from a radar standpoint, and now from a satellite standpoint of what does that signature look like? Because oftentimes especially for the Hibbing airport, it's kind of far away from being able to see it not necessarily on the radar. So can we pull any satellite signatures off that, because it does impact the terminal at Hibbing.
All right, thank you. So one other additional thing. So Juan reminded me that she did a satellite book club presentation a few weeks ago. That's what I was thinking, and there's a link there in the chat to the YouTube if you happen to miss that. So check that out to learn more about some of the microwave capabilities for snowfall rate. And that's all that I'm seeing. Oh, here's another question, or maybe it's a comment from Curtis Seaman. The 1.24 micrometer channel on VIIRS and the upcoming med image is highly sensitive to snow particle size. Sierra has developed a snowmelt RGB for VIIRS and is working with Alaska region on to validate the product. So that's something to look for. I personally am not particularly familiar with 1.24, mainly because it's not on ABI, but we're more with ABI than with VIIRS. But something to check out if you haven't, and let's keep an eye out for that product from Sierra.
Sure, no, that sounds awesome, because for us, getting back to that the snowpack, it's, this is MODIS, right? And so we got the high res, but is there any, can we tease out characteristics from that? Because there's the ice products that give us age, thickness, comfort, temperature. Is there something that we can bring out? Boy, this is crusted and old snow versus this is fresher snow that may not be so locked up yet. And being able to see that on a in an all across your forecast domain would be huge.
Thanks, Patrick. Okay, last call for questions. Type them in the chat if you have anything. All right, well, thanks again, Patrick. I don't know if Jordan or Kashad or someone wants to say any closing words here.
Yeah, I'll just wrap it up. Thank you, Dan, for leading that discussion. And once again, thank you, Patrick, for being here today and putting together this presentation. A really good summary of a lot of winter techniques and challenges that are out there. Just remind everybody, once again, we'll be off for the holidays, back on Thursday, January 7th. If you're trying to get the Tower SRPM at your office and have challenges doing so, or otherwise need to reach out to our Tower S team, they are standing by and willing to help. So please feel free to reach out to get the latest menus and product configurations for satellite data into your AWIPS. With that, it's a wrap on 2020 and the Satellite Book Club. We'll see you in 2021. Take care.
Real quick, Carl put in a last second comment there about the ALPW products and a plug for that. So check that out in the chat and we'll close now. Thanks.
Thank you, guys.